Bismillah ar-Rahman ar-Rahim. Today our topic is acceleration and then deceleration. Okay, we start by a numerical. I will give you a numerical and then we will discuss it and we'll extend this idea. The question number 1. There is an object resting on a horizontal surface. This is an object which is resting on a horizontal surface. Its mass is 7 kg and the coefficient of friction between the surface and the block is 0.4. Now we apply a force on this object. This force is, the value of this force is 45 Newton. This force of 45 Newton acts on this mass of 7 kg. Yumna, please keep your calculator along with you, okay? Force of 45 Newton acts on this mass of 7 kg for 30 seconds. The question is, calculate the total distance traveled by this 7 kg mass. Calculate the total distance this 7 kg mass. Sketch its velocity time graph, acceleration time graph, and displacement time graph. So this is our agenda of today. Okay. Step number 1. Step number 1 is that show all the forces acting on this object. Show all the forces acting. This is the first. We are starting our solution from here and show all the forces acting on this. So all the forces acting on this object. This is 7g mg. This is normal contact force, which is also equal to 7g. And the frictional force that is acting opposite to the motion .4 R, okay? So these are the 4 forces acting on it, okay? So there are 4 forces acting on it, okay? Now, what is the acceleration of this object towards right? This is our part number 2. So its acceleration, we will call it as A1, is equal to forward force, force in the forward direction, minus force in the reverse direction or backward direction, F1 minus F2 over mass 45 Newton minus 0.4 R over 7. So it is equal to 45 Newton 0.4 and R is equal to 7G, taking G as a 10. It's 70 over 7. Can you tell me the value of acceleration, please? Please do this calculation.
6.03.
6.03 meter per second square. Okay. Now, starting from rest, this force acts for 30 seconds. Hence, the acceleration is for 30 seconds. Okay. So, the third point is velocity after 30 seconds is V is equal to U plus 80. 0 plus acceleration is 6.0203 and time is 30. So what is our answer? Please do the calculation.
180.9.
9 meter per second. Okay. Well, if you are you sure that acceleration is 6.03? 0.4 when multiplied to 7 give us the value of 0.28. 28. 45 minus 28 is. But I think the acceleration that you've calculated is not right.
Yes, I thought it was 7, not 70. It's 2.43.
2.43?
43. Yes.
Okay. Now, inserting this value 2.43. Now, what is our answer over here? What is this, the value of the velocity after 30 seconds?
72.9.
72.9. Okay. Okay. Now, the distance traveled. Distance traveled in first 30 seconds. Distance traveled in the first 30 seconds is please do this calculation. I am coming in 10 seconds.
Okay.
Okay. What is the answer of this calculation?
1093.5.
1093.5 meters. Okay. Now, when the driving force moves away, what happens then? Okay. Now the driving force is not acting anymore. Okay. This 45 Newton doesn't exist. I think we should erase this whole thing. We should redraw it. This motion has two stages. In the stage 1, it was accelerating. It started from rest. Its final velocity was 72.9 meter per second. Its acceleration in this stage number 1 was 2.43. And the distance it traveled was 1093.5 meter. Okay. Now, after that, this is the distance stage number 2, in which it travels a distance of s2 and it comes to rest. Okay, it slows down until it comes to rest over here, and its final velocity in this stage 2 is 0. 72.9 meter per second. This 72.9 meter per second was the final velocity of the stage 1, and now it is the initial velocity of the stage 2. Okay, now when the driving force is no more, the body will move on because of its inertia, and it will be decelerating. For S2, we call it motion due to inertia. We call it motion due to inertia. Okay. Oh, what forces are acting on it? Weight mg, normal contact force, and the frictional force is mu r. Okay. So it's only mu r which is acting. There is no force in the direction of motion. Okay. So the force which is acting is opposite to the direction of motion, and it is trying to stop the body. So there is no forward force, and the decelerating force is minus mu r over m, minus mu mg over m, minus mu g, and the value of mu is 0.4, the value of g is 10. So it's minus 4 meter per second square, and I will call it A2, the acceleration of the stage 2. Okay, we call it A2. Now, in this stage, we have the final velocity of the previous stage will become the initial value of this stage. Okay, and the final velocity now over here is 0, and the deceleration is minus 4 meter per second square. Now, using these values, I can calculate the time v minus u upon a. It's 0 minus 72.9 over minus 4. What is the answer of this calculation? 18.225 seconds, I think. Please check it if it is right.
Yes.
It is okay. We can round it off. We can just write 18.2 seconds. Okay. Now, we can calculate the distance S2. Please calculate this value.
663.4.
6.
3.
There are 3 sixes.
No, 2 6s. And then
6.
3.4.
3.4 meter. Okay. Now, our acceleration time graph would be like this. Our initial acceleration was what? It was 2.43. 2.43 meter per second square for 30 seconds. Okay. Then a deceleration of minus 4. A deceleration of minus 4. for 18.2 seconds. So it's 48.2. Okay. Do you understand it?
Yes.
And then we can draw the velocity time graph. The velocity reached was 72.9. And then it decelerated to rest. And this is how its velocity time graph, okay? And its displacement time graph is like this. While accelerating and then while decelerating. This is 30. This is 48.2. And over here, the first distance traveled was 1093. And then please add 1093.5 and 663.4. Please add 1093 5 plus 663.4. So what is this answer? Please calculate it.
1756.9. 56.9.
1756.9. Okay. Meter. I hope you understand what I have taught. Now we will do a question quite similar to this, but in a situation where a body is thrown in the upward direction. Okay. No, we will deal the same concept in vertical motion. Okay. Consider a situation where this is a block. The block has a mass of 7 kg again, and it is attached to a string. Okay. It is attached to a string. This string then goes over a pulley, and then it is connected to some kind of motor or so. So there is a force of 120 Newton X on it. A force of what? 120 Newton X on 7 kg. But this force acts only for 5 seconds. Okay. A force of 120 Newton acts on the 7 kg mass for 5 seconds. Calculate the total distance moved by 7 kg in the upward direction. A force of 120 Newton acts on the 7 kg mass for 5 seconds. Calculate the total distance moved by 7 kg in the upward direction. Okay. We will also calculate accelerations. We will also calculate the velocities. And So we add another question, that sketch velocity time graph, acceleration time graph, and displacement time graph. Okay. And we will just erase this pulley and every string like a string. Okay. So now we have this mass and a force of 120 Newton X on it. Okay. This motion also has two stages. The stage number one is in which it is accelerating in the upward direction. And as it accelerates in the upward direction, its velocity will increase, becoming maximum at t is equal to 5 seconds. The moment this 120 Newton vanishes, it goes away, the body will not just come to rest instantly, rather it'll keep on moving in the upward direction. And this time this distance we call this distance s2. And this second, we declare this motion in the second stage as the motion due to inertia. And if you want to know what is inertia, inertia is the inability of matter to change its state of rest or of uniform motion without the application of force. So when 120 Newton finishes, the body will not come to rest instantly, rather it will move some distance up. Okay. So in the stage number 2, its velocity will start decreasing, becoming 0 again. Okay, so we call this velocity v at the end of t is equal to 5. Okay, we call this velocity v at the end of t is equal to 5. This velocity is the final velocity for the stage number 1, and it is the initial velocity for the stage number 2. Okay. We will call time t1 for the stage number 1, which is t. For the value of t1 we know it's 5 seconds, but we do not know this value of t2. Okay. Okay, now what is the acceleration of stage 1? What is the acceleration of stage 1? Okay. What is the acceleration of stage number 1? Solution. Stage 1. Acceleration is 120 minus weight over 7. 120 is the force in the forward direction or in the direction of motion, and the weight is in force in the direction opposite to the motion. So 120 minus 70 over 7, it is equal to what? 50 over 7. So what is this acceleration? It's, I think, 7.07 meter per second square. Is it?
7.14.
7.14. Okay. Okay. No, we calculate the velocity. T1 is 5 seconds. Please calculate this velocity.
35.7.
35.7 meter per second. Okay. Now in the stage 2, what will be the acceleration in the stage 2? When this force of 120 Newton is taken away, what is the value of acceleration in the stage 2? Can you tell me? Can you guess?
Don't we have to calculate S1?
Oh, yes, we have to. Sorry, apologies. I forget the calculation of S1. Okay. For S1, you can apply any formula. You can use ut plus half at square. You can use u plus v over 2 into time. You can also use v square minus u square over 2a. And you can even use vt minus half at square. Okay. So choosing the second one, 0 plus 35.7 over 2 into 5. What is the answer of this calculation?
89.3.
89.3 meters. Okay. So what is the acceleration in the stage 2? Can you guess?
10 meters per second squared.
Minus 10. You're right. It's minus 10. But since it's moving up, since it is moving up, so it's minus 10. Okay.
Okay.
It's minus 10 meter per second. Do you have any question to ask?
No.
Okay. Final speed is 0. You know, the final speed of the previous stage is the initial speed of this stage. Okay, 3.57 seconds. Okay. Initial velocity of this stage is 35.7. Final is 0 over 2. And the time is 3.5 seconds. What is the answer?
62.7.
What?
63.7.
63.7 meters. Okay. Now I think we have enough information that we can draw the graphs. We can easily draw them. Okay. We make the screen look smaller. And then the velocity increases in the first 5 seconds and then decreases to 0 at 8.57 seconds. I have added this 3.57 in the 5 seconds to get this value of 8.57. And the velocity, final velocity was the velocity in the final velocity for the stage number 1 and initial velocity for the stage number 2 is 35.7 meter per second. Now displacement, we know it's 89.3 meter in the first stage. And then please add 89.3 with 63.7. Add 89. It will become 90, 90, and 153. Okay. 153.7. So it's 8.57. And in the case of acceleration, it's 7.14. And then it's minus 10 for 3.57 seconds. And now this is the final verdict. Is there any question in it?
They're in stage 2. Why
Yes.
isn't there the 120 Newton force?
Why they said that the string got broke in the stage 2? The string got the string snapped. And when the string snapped, there was no force acting on 7 kg but still 7 kg continued to move up because of its inertia. For example, if you throw a ball in the upward direction, that motion has two directions, the two stages. While it is in your hand, and as you're moving your hand in the upward direction, for that 1 feet or so, let's say that your hand moves up in 1 foot along the motion along the ball, and you apply some force in that 1 feet, the ball is accelerating. Okay, once it leaves your hand, the stage 2 of its motion begins, and in that stage it just keeps on decelerating because the force that you exerted is not acting anymore. So anything which is thrown up, it has its motion always consists of two stages. The first stage, in which it is being given some velocity and some big upward force more than its weight is acting in the upward direction, and then when that force finishes off, the body moves up some distance, and that this motion is called motion due to inertia. Yumna, do you understand it?
Yes.
Okay. Okay. Now, question number 3 is also similar. It is of the same type. Okay. And it's on an inclined plane. Okay. This is an inclined plane, and the angle of inclination is 30 degree. An object is resting on this inclined plane, and its weight is, say, it's again, we call its mass as 7 kg. Okay. The mass is 7 kg and the coefficient of friction is 0.4. Okay. An object X on it, a force X on it in the upward direction. A force X on it in the upward direction. Okay. This force, the value of this force is 39 Newton. This force acts for, say, 20 seconds. And then it stops acting. It might be a string. It might be, this force might be acting through a string which snaps after 20 seconds, or by any means it doesn't act after 20 seconds. So what will happen to this 7 kg mass? It will accelerate in the upward direction. Its velocity will be maximum after t is equal to 20 seconds. And then when the 39 Newton force finishes off, its stage 2 of its motion will begin. Okay, so this is acceleration. This is acceleration. And now we have deceleration. Now we have deceleration. Okay. And we also call this motion as motion due to inertia. Stage 2 is called motion due to inertia. Okay. So the speed will increase. The speed will increase. And then it will decrease. Okay. So over here, I draw the velocity vector. Its longest at t is equal to 20, then it'll start decreasing again, becoming 0 at the end of the stage number 2. Okay, so this is stage 2, and this is stage 1. Okay, its acceleration is a1, its displacement is s1. Okay, and let's do calculations to find this. The very first thing that we do is that we apply, we show all the forces acting on it. We show all the forces acting. Okay, so this is 7g cos of 30 degree. This is normal contact force. And this is 7g sine of 30 degree and mu r. Can you calculate the value of 7g sine of 30 degree plus mu r 7g sine of 30 degree plus 0.4 into 7g cos of 30 degree. Please do this calculation and let me know the answer. What is the answer of this value?
59.2.
59.2. Okay, that means this 35 Newton will not help it to go up. Since I am making the question myself, let me change the value of the driving force. So this is 74 Newton. Let us suppose that force of 74 Newton acts on it for t is equal to for first 20 seconds. So what is the acceleration of the first stage? 74 minus this 7g sine of 30 plus mu r over 7 kg. A1 is equal to 74 minus 59.2 over 7. Please do this calculation and let me know.
$2.11.
2.11.
11. Yes.
2.11.
Yes.
Okay. Okay. Now calculate the distance S1 using all the formulas that you know. What is the value of S1? You can use this U plus V over 2 into time. You can even use UT plus half AT square. Or you can use V square minus, oh, you haven't calculated final velocity yet. Okay, first of all, let us calculate that. Okay. Now V is equal to U plus A1 T1. Acceleration A1 is 2.11 and time T1 is 20 seconds. Please calculate it. What is the answer of this? Hello?
42.2.
42.2 meter per second. Okay. And what is the distance traveled in this stage? You can use U plus V over 2 into time. 0 plus 42.2 over 2 and the time is 20. It's 422 meters. Okay. Now when this 74 Newton stops acting, when this 74 Newton stops acting, then what is the new acceleration? What is the new acceleration in the stage 2? You know, this 74 Newton, you will put a 0 over here and then we will change the subscript. This is the new acceleration, stage 2. Because the driving force 74 Newton is not acting. So what is the value of deceleration produced now? It's my 59.2 over 7. You know, I brought 59.2 Newton from here. We have already calculated it. Okay. You can see it from here. Okay. Please calculate it.
Minus 8.46.
minus 8.46 meter per second square. Okay. Now calculate the time t2 is equal to v minus u upon a. The final speed of the previous final velocity of the previous stage will become the initial velocity of this stage. Please do calculate this time t2.
4.9.
4.9. 4.9 seconds. Okay. Now calculate S2. Using u plus v over into t, u plus u is 42.2, final speed is 0, and the time is 4.9 seconds. This is how you can calculate S2. Do you understand this thing? Hello?
Yes.
Okay. So please do this calculation.
103.4.
10.
3.4.
3.1 meters. Okay. And you can easily sketch its acceleration time graph, which will be like this. And then its velocity time graph, which will be like this. And then its displacement time graph. So beta, these three stages, these three questions were very important, and they'll help you to build your concepts of statistics or skills of skills of mechanics to a very a better degree of level. Okay, you have understood it?
Yes.